This lesson is on section 2.3, solving radical equations. Radical equations can be solved either algebraically or graphically. Algebraic solutions give exact answers, but can sometimes result in extraneous roots, so we always have to check our answers when we solve algebraically. Graphical solutions are easier to find, but they're only approximate solutions, so we can't get exact values all the time. You must be able to solve radical equations both graphically and algebraically. Let's start with graphically. Solutions or roots of the radical equation are found two ways. One, graph the function and determine the x-intercepts, so graphing one equation, or graph the system using y1 and y2 to graph the left side as y1, right side as y2, and then determine the intersection points. The solutions would be the x values of the intersection points. Let's try this both ways. Solve x plus 3 equals the square root of 12 minus 2x squared graphically. So the first way, we want to graph the function and determine the x-intercepts. We want to graph one function. Right now I see that I have two sides, information on two sides here, x plus 3, and then our root part. We need to move everything to one side. So it doesn't matter which side you move things to. I am just going to subtract square root 12 minus 2x squared. So I get y equals x plus 3 minus the square root of 12 minus 2x squared. Then I go to my calculator. Y equals, clear what we had, type in our equation here, x plus 3 minus the square root of 12 minus 2x squared, enter, graph. So we get this really funky looking graph for this radical function. Let's find our x-intercepts. Second trace, we want number 2, the 0 on the Casio, it's called the roots. I need to be left bound of that point. So I'm going to start with this one here. Hit enter, that would be, so I'm doing the right x-intercept first, the one that's like right there. So I'm going to put my dot here, that's left of that point, hit enter. Put my dot here, that is right of that x-intercept, hit enter. And then it says it's x equals 0.414. So I can graph this as well, so about around 0.5 for graphing purposes. And then x equals 0.414. Our next point, let's see if we can do this, second trace, number 2. I want to be left of that point, so my y value, if I look at my y value, it is positive, which means it's above the x-axis, 0.086. So that should technically be left of the x-intercept. So let's see if it's going to work for me. Hit enter, then I go right bound, so drop down here somewhere, hit enter, and there we go. It says it is x equals negative 2.414. So those two values, graph it, negative 2.5-ish. I can find my minimum value, left bound, right bound, so negative 1.45 and negative 1, somewhere in there. So it looks something like this. Let's write a note here. When we use method 1 for solving graphically, our solutions are the x-intercepts, which are also called the zeros, and the roots. Let's do the second method now. Go back to y equals, clear that. We're going to graph two equations. One of them is the left side, x plus 3, and the other one will be the right side, square root of 12 minus 2x squared, x plus 3, enter root 12 minus 2x squared. Graph, and we get this funky looking graph. X plus 3, that's a linear with a slope of 1 and a y-intercept of 3. Let's graph that. Y-intercept at 3, slope positive 1, so up 1, right 1, up 1, right 1, up 1, right 1, and then down into the left 1, down into the left, down into the left. I can join my points with a line. On to the next one. Let's just find our intersection points. Second trace 5, enter, enter, enter. And it tells me the one on the right is x equals 0.414 and y equals 3.414. So we can graph that, 0.414 and 3.414. So about there. Then we'll do the, we'll write that down, x equals 0.414. And then second trace number 5. We want to move our little dot closer to the intersection point we want now. Enter. It's going to jump to the next graph. Again, move it closer. Enter, enter. And it is negative 2.414. And y is 0.586. So about there. And then we can just join those points together, continue it down to make our graph. Not beautiful, but that's okay. So we see that the x values of the intersection points for method 2 are the same as the x-intercepts, zeros, roots for the method 1. So either graphing one equation and finding the x-intercepts, or graphing two equations and finding the x values of the intersection points. Put a note on this side for method 2. Solutions are x values of intersection points. Next, let's solve algebraically. First step is to state the restrictions on the variable before we do any manipulating of the function. Step 2 is to isolate the radical and square both sides of the equation to eliminate the radical. Once the radical is eliminated, then we solve for x. Step 3, always check the solutions by substituting your answers into the original equation to check for extraneous roots and eliminate any extraneous roots. First example, state any restrictions on the variable, then algebraically determine the roots of each equation. So starting with restrictions, the thing under the radical, the radicand it's called, has to be greater than or equal to 0. So start with the radicand, in this case that is 12 minus x, has to be greater than or equal to 0. Then we want to solve for x, so we would subtract 12 from both sides, so we get negative x greater than or equal to negative 12. Then we need to divide by negative 1. Remember, when we divide or multiply by a negative, the inequality sign flips. So we would get x is less than or equal to negative 12 divided by negative 1 would be positive 12. Okay, now we can start manipulating the equation. We want to isolate the radical, so I'm going to subtract 4 from both sides. And then I would get 7 minus 4 is 3 equals the square root of 12 minus x. Just going to make this bigger here. Now that we've isolated the radical, we want to square both sides because the opposite of square rooting is squaring. So that will get rid of our root. 3 squared is 9 equals 12 minus x. And now we can isolate the variable. If we subtract 9 from both sides and add x to both sides, then we would have x equals 12 minus 9 is 3. So we get one solution in this case. We need to check our solution. Every time you do algebraic solving of radicals, you need to check your solution to make sure it's not an extraneous root. So sub it back in to our original. 7 equals the square root of 12 minus 3, and then plus 4 outside the root. 7 equals 12 minus 3 is 9, so square root of 9 plus 4. 7 equals square root of 9 is 3 plus 4. 7 equals 7. That's true. Therefore, x equals to 3 is a solution. And then we had our restrictions here. Next one's gonna take up a bit more space, so I'm just gonna block off all of this here. Okay, so restrictions first. Take the thing that's under the square root, the radicand. 12 minus 2x squared, that has to be greater than or equal to 0. Subtract 12 from both sides, we get negative 2x squared is greater than or equal to negative 12. You're going to divide by negative 2. That's going to flip our inequality sign because we're dividing by a negative. X squared is less than or equal to negative 12 divided by negative 2 is positive 6. Next, we need to take the square root of both sides, but we don't know if x was a positive or a negative, and when we square it, it's going to be a positive. So that's when we have to do plus minus. But in this case, because it's an inequality, applying the negative to the other side is multiplying or dividing by a negative. So we have to look at this in two separate cases. We have the positive square root x squared is less than or equal to square root 6. And then that's just going to be x is less than or equal to square root 6. We can calculate that, exit this, square root 6. So x has to be less than or equal to 2.449 ... And then the other option, the other situation, we have negative square root x squared is less than or equal to square root 6. We need to multiply or divide by negative 1 to move the negative over. So we get x is greater than or equal to, because the sign is switching since we're multiplying or dividing by a negative, and then the negative square root 6, which would mean that x has to be greater than or equal to negative 2.449, etc. That's our restrictions. Now we want to solve. First step is to isolate the radical. In this case, the radical is already isolated. So next step is to square both sides so that we can get rid of the root sign. We have x plus 3 squared. That's a binomial times a binomial. Okay, so x times x is x squared. X times 3 is 3x. 3 times x is 3x plus 3x plus 3x. And 3 times 3 is 9. Then it equals 2. We just got rid of the root sign, so we have 12 minus 2x squared. We want to combine like terms. X squared plus 6x plus 9 equals 12 minus 2x squared. We want to move everything to one side. Subtract 12 and add 2x squared. We get 3x squared plus 6x minus 3 equals to 0. And then we want to solve this some algebraic method, so factoring or quadratic formula. I'm going to use the quadratic formula here because I am able to see that this is not going to be factorable. X equals negative b, negative 6, plus or minus the square root of b squared, 6 squared, minus 4 times a, which is 3, times c, which is negative 3, all divided by 2 times a, which is 3. We want to simplify, but not just calculate, because we could want exact values here. So let's calculate what's under our square root. 6 squared minus 4 times 3 times negative 3 is 72. And then 2 times 3 is 6. Can we simplify this radical at all? Square root of 72. So numbers, perfect square numbers are 4, 9, 16, 25, 36, etc. Can we divide 72 by any of those numbers? Well, 72 divided by 36 is 2. So we can simplify it as x equals negative 6 plus or minus square root of 36 times 2 over 6. And then the 36 can come out. The square root of 36 is 6. We get x equals negative 6 plus or minus 6 square root 2 divided by 6. Then we look at our coefficients. We have negative 6. 6, the coefficient is a number in front of the root, and then we have a 6 on the bottom. If all of those numbers can be divided by a common factor, then we can do that. We get x equals negative 6 divided by 6 is negative 1, plus or minus 6 divided by 6 is 1, and then square root 2. I don't need to write that one in front of the root 2. And then 6 divided by 6 is 1. I don't need to write this in a fraction anymore because it's just a denominator of 1. So x equals negative 1 plus or minus square root 2 is how I would typically write my final answer. So that is the answer in exact value, fully simplified. Now we need to check our answers, and to do that it's usually simpler if we have a decimal answer instead of an exact value. So calculate negative 1 plus square root 2, which is 0.414, and then negative 1 minus square root 2 is negative 2.414, etc. So when we plug these in, because we're rounding, we might not get exactly the same thing on the left side and the right side, but we should get something pretty darn close. Okay, so if you use at least a few numbers after the decimal, you should get something very close. So check that the left side equals the right side for both of our answers. I'm going to start with 0.414, 0.414, plus 3. And then on the left side, we have the square root of 12 minus 2 times x, which is 0.414 squared. Calculate that. On the left side, we get 3.414. And on the right side, second function, square root 12 minus 2 times bracket 0.414 close bracket squared, and we get 3.414, etc. So same on the left and the right, so we know it's true. Our next solution was negative 2.414, negative 2.414 plus 3 equals square root of 12 minus 2 times negative 2.414 squared. Calculate the left side, negative 2.414 plus 3, 0.586. And then the right side, root of 12 minus 2 times bracket negative 2.414 close bracket squared, enter, 0.5875. So yes, those are very close. We'll call them the same. Next example, solve y equals the square root of x plus 3 minus 2, both graphically and algebraically. And then it says also to graph using transformations. So square root of x plus 3 and then minus 2. This would be y equals the square root of x shifted 2 down because our k value is negative 2, and then 3 left because our h value would be negative 3. So 3 left, 2 down. Okay, so let's just draw the basic square root x. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. If we shift that 2 down and 3 left, first point at 0, 0 goes down 2 and 3 left. Just going to zoom in on this question. And then the point at 1, 1 goes down 2 and left 3. The point at 4, 2 goes down 2 and left 3. And then the point at 9, 3 goes down 2 and left 3. So we get this transformed radical function in blue. So this purple one is y equals square root of x, and the blue one is y equals square root of x plus 3 minus 2. So we can see that our x-intercept is here at x equals to 1. So that would be our solution, x equals 1. And then algebraically, first step is to do our restrictions. Take the radicand, which is x plus 3, set that greater than or equal to 0, subtract 3 from both sides. X has to be greater than or equal to negative 3. Then we want to isolate the root. Square root of x plus 3 minus 2 equals 0. Add 2 to both sides. We get root of x plus 3 equals 2. Square both sides to get rid of the root. We get x plus 3 equals 2 times 2 is 4. Subtract 3, x equals 1. Now we need to check to make sure it works. We plug in 1, square root of 1 plus 3, and then minus 2 equals 0. Square root of 4 minus 2 equals 0. 2 minus 2 equals 0. 0 equals 0. So yes, that solution does work. It's not an extraneous root. So we have x equals 1 and restrictions of x has to be greater than or equal to negative 3. Solve 4 minus x equals the square root of 6 minus x graphically and also algebraically. Graphically, you can do either method, graphing one function and finding the x-intercept. or graphing two functions and finding any intersection points, and the x values would be the solutions. So I'm going to do it that way. I'm going to do my y1 equals 4 minus x, and my y2 equals the square root of 6 minus x. Bring up my graphing calculator. Clear that. We have 4 minus x and the root of 6 minus x. Graph, and here's our graph. So the first one, y1, is a linear. It's got a y-intercept at 4, and it's got a slope of -1. So as it goes to the right, the graph is going down. Down 1, right 1, down 1, right 1, down 1, right 1, etc. And I can join those points with a line. And then the next one, we could find the intersection point, number 5. Enter, enter, enter. We see there's only one, so it intersects at x equals 2 and y equals 2. And then we could find the y-intercept to help us graph the rest. So I can trace y-intercept would be the value, number 1, and put in 0. Okay, tells us that one, and then we jump down, and I don't know why it does that. 0.5, negative 0.025, negative 0.1. Anyway, somewhere around 2.5. Strange little calculator. And maybe I can find the x-intercepts. Number 2, left bound, enter, right bound, see if it goes right. Nope, it doesn't. So it looks like it's around x equals to 6, 5.975, so approximately there. Might not actually hit the x-axis, but somewhere in there. And then we can sketch our graph. And there we have it. So our solution is the x value of the intersection point. X equals 2. Then we want to solve algebraically. Do our restrictions first. 6 minus x has to be greater than or equal to 0. Subtract 6, negative x has to be greater than or equal to negative 6. Divide by -1, which flips the inequality sign. X has to be less than or equal to negative 6 divided by -1 is positive 6. Those are our restrictions. Then we want to solve. We already have the radical isolated, so square both sides. We're squaring a binomial, so 4 times 4. This time I can write it out, I have more space. 4 minus x times 4 minus x equals, and then on the left side we just lose our radical sign, 6 minus x. 4 times 4 is 16. 4 times negative x is negative 4x. Negative x times 4 is negative 4x. And negative x times negative x is positive x squared equals to 6 minus x. Let's combine our like terms and put it in descending order. X squared minus 8x plus 16 equals 6 minus x. We want to add x to both sides and subtract 6 from both sides. We get x squared minus 7x plus 10 equals 0. And then we want to solve this algebraically. I can tell that this one is factorable, so I'm going to factor it. 2 factors of 10 that add to negative 7 would be negative 5 and negative 2. So I get x minus 5 x minus 2 equals to 0. And then I solve each of those factors. X would have to equal 5 and x would have to equal 2. Next step is to check each of our solutions. We already saw from the graph that our only solution is x equals to 2, so we should expect that x equals 5 is an extraneous root. Let's check it algebraically. We are subbing in the values. I'll start with x equals to 2. Zoom in here. X equals 2, and we are plugging it into our original here. 4 minus 2 equals the square root of 6 minus 2. 4 minus 2 is 2. Square root of 6 minus 2 is 4. 2 equals 2. That's true. So we see that x equals 2 is a solution as we expected. Next we want to do x equals 5. We plug it in. 4 minus 5 equals the square root of 6 minus 5. 4 minus 5 is negative 1 equals the square root of 6 minus 5 is 1. We have negative 1 on the left. Square root of 1 is positive 1. So we have negative 1 equals to positive 1. This is not true. So that tells us that x equals 5 is not a solution. It's an extraneous root, and our solution is x equals to 2 with restrictions on x, that x has to be less than or equal to 6. The equation square root of x minus 5 plus 4 equals 1 has no solution. Verify this graphically and algebraically. Again, we can graph two functions and find the x values of the intersection points, or we can graph one function and find the x-intercepts of that function for the solutions. I'm going to graph two different functions, clear and clear. It doesn't matter which way you do, you get the same result. We have square root x minus 5, and then outside the root is plus 4, and then we just have 1 as our second graph. So we get this. We have a line at y equals to 1, and then we have this curve here. The endpoint is 5 and 4, so about there. It doesn't really matter exactly how it looks, because the point is to show that it has no solution. So it's going off like that somehow. And this is y equals square root of x minus 5 plus 4. So we can clearly see from the graph that these two graphs do not intersect each other, which would mean there's no solution. Do not intersect, therefore no solution. That's graphically, and then we can do this algebraically as well. So let's first always start with our restrictions. Taking our radicand, x minus 5, setting it greater than or equal to 0, adding 5 to both sides. X has to be greater than or equal to 5. Those are our restrictions. Next, we're going to solve. Square root x minus 5 plus 4 is equal to 1. Subtract 4 from both sides. We get square root of x minus 5 equals 1 take away 4 is negative 3. We want to get rid of the root, so square both sides now. We get x minus 5 equals negative 3 squared is positive 9. Then add 5 to both sides to get 14. Then we want to check. So we have our solution we think is x equals 14, but we can see from the graph that that's not going to be correct. So we check it. We plug it in, square root of 14 minus 5 plus 4 equals 1. Square root of 14 minus 5 is square root of 9 plus 4 equals 1. Square root of 9 is 3 plus 4 equals 1. 3 plus 4 is 7, which definitely does not equal to 1. Therefore, 14 is an extraneous root, and there are no solutions. Determine the initial velocity required for a roller coaster design if the velocity is 26 meters per second at the bottom of a 34-meter vertical drop. We have the function v equals the square root of v0 squared plus 2 times a times d, where v equals velocity, d is drop, and a is 9.8 meters per second squared. We have some information in here. Velocity is 26 meters per second, and then it's a 34-meter vertical drop. You can start with the original function. V equals the square root of v0 squared plus 2ad, and plug in our information. Our velocity was 26 equals to v0 squared plus 2 times a, which is 9.8, times d, which was 34. 26 equals square root of v0 squared. Let's calculate 2 times 9.8 times 34, and we get 666.4. We want to get rid of the root, so we're going to square both sides, and then we get 26 squared is 676 is equal to v0 squared plus 666.4. We're going to subtract 666.4 from both sides. Gives us v0 squared, so 676 minus 666.4, 9.6 is equal to v0 squared. Now we need to get rid of the squared, so we have to square root both sides, but we don't know if v0 started as a positive or negative, so we're doing plus minus square root plus minus square root, which gives us two possibilities. We have v0 equals plus or minus the square root of 9.6 is 3.098. We'll round it to 3.1. We'll say that's meters per second. It's velocity. So what does it mean, the plus minus? Well, it's the same speed but different direction. The sign for velocity represents the direction. Put a note here. Same speed but opposite direction. Which direction do we think it should go? If we look at our question, it says determine the initial velocity required for a roller coaster design if the velocity is 26 meters per second at the bottom of a 34-meter vertical drop. So since the velocity at the bottom of the drop is 26 meters per second, positive 26 meters per second, I would say that the initial velocity of the roller coaster should be going the same direction as it is at the bottom of the drop. So that would be a positive velocity. So in this case, it would be velocity equals positive 3.1 meters per second. Okay, and that's the same direction as the bottom of the drop. And we can check it. So V is 26 equals to 3.1 squared plus 2 times 9.8 times 34. 26 equals the square root. Let's do 3.1 squared plus 2 times 9.8 times 34. Calculate that, we get 676.01. If we take the square root of that, square root my answer, I get 26 equals 26.00001. So yes, that is correct. So our velocity is 3.1 meters per second. That brings us to the end of the Chapter 2 notes.